Hello and welcome to this episode of Weekly Bytes, where we take a tech topic and break it down for you in under 10 minutes. This week we're going over Terraform Resources, what they are, the arguments they take, meta-arguments, and how Terraform deals with all of this. So let's get right into it. What are Terraform Resources? Well, with infrastructure as code, building stuff is kind of like putting Lego together, and Terraform Resources are the building blocks of your infrastructure. And each one of these building blocks could represent a different thing. It could be a virtual machine, a network, or even something as simple as a local file. But we'll just say that a Terraform resource is a thing that you can provision, and as long as you declare it, you can deploy a thing with Terraform. Let's go into VS Code here and take a closer look at the syntax for defining Terraform resources. I'll be sharing the link to this repo in the description so you can follow these examples yourself. We'll start off with the resource keyword. Then we'll give the resource type, the first part being the provider name. Next, we'll be giving the resource that provider provides. In this case, it's a local file. And lastly, we'll give our new resource a name. In our case, we're just going to create a resource called foo. And then we'll open up curly braces and close them here. So you'll see right off the bat we've got a problem here. We're missing a required attribute. And that brings us to our next point. Arguments. Each resource type has its own set of arguments, and it is dependent on the type of provider that you're using. In our case, we're using the local provider and we're creating a file. So in this case, without a file name, we can't create a file. Therefore, it is required. So we're going to start by giving this file some content. Then we're going to use the path.module variable in our file name, and we're going to make our file's name foo.text. So I'm going to start by running a Terraform init. If you're not too sure what a Terraform init is, you might want to watch this video in the right hand corner. Then the next part of the Terraform workflow is to do a Terraform plan. And we'll confirm here that we're creating a file called foo.text in our current directory with the content of bar. So if you're not sure what plan is, you'll also see another link in the right hand corner. So now we'll do the last part of the Terraform workflow by doing a Terraform apply of our plan. And you'll see that we've created a file called foo.text. Let's move on to our next point. Meta arguments. Meta arguments are special arguments that modify the behavior of resources. These are not specific to any resource type and can be used across all resources. We're just going to go over the ones that matter right now for this lesson. We're looking at count. Count allows you to create multiple instances of a resource and is usually best for when we're creating things that are kind of identical. When using count, a count object is created which has an index property, as you can see here. This property is a number starting from 0 and going up by 1 each time. So, if we do that, we can start from 0 and go all the way up to 1,000. Should we create 1,000 files? And you'll see our screen is going absolutely mad, and we are just creating loads and loads and loads of files. This is kind of a testament to the power of Terraform and how many resources you can create and template out. Great, so now we have 1,000 files. What do we do? Terraform destroy. Now that that's complete, you'll see that we actually destroyed 1,000 files. As quick as we created them, we got rid of them too. The next thing we have to go over is the for each meta argument, and its purpose is to create resources for each item in a map or set. We're going to start with the set. So the keen eye will notice that we're using the toSet function here. This is because for each only works with maps and sets, not lists. According to Terraform's documentation, there actually isn't literal syntax to create a set, hence we use the toSet function to explicitly convert a list to a set. But hold up, why does it matter what the type is? They look pretty similar, right? Well, the difference is that a set is unordered and unique, while a list is ordered and can contain duplicates. So if you try to create a file with the same name twice using a list, it will throw an error. So after we do a Terraform plan, and we can confirm that we are indeed creating files called A, B, and C.txt, when we run that with Terraform apply, you'll see that we get that expected result. Great, so now we have a way we can create files with different names, but they all have the same content. What if we want to have different content? That's where maps come in. So if we go and define a map here, you'll see that the syntax is a bit different. We have some key value pairs here. We've got file1, file2, content1, and content2. And what you'll see is we have this each object that's available now whenever we use the for each meta argument. And here we're using each.value and each.key, where each.value is content1 and 2, and each.key is file 1 and 2. The key is on the left, the value is on the right. So if we look how that looks in the Terraform console, you'll see that it's a key value pair. So if we do our plan here, you'll see that it will be creating two files, one called file1, one called file2, with content1 and content2. And if we apply that plan, you'll see that we've got the expected result here. So sometimes we can't always use the implicit dependency, and sometimes the relationship isn't always clear between Terraform resources. So to get around this, we can use the depends on meta argument to make sure one resource is only created after another resource. So the way that will kind of look is, in our example, we'll be creating file 1 and file 2, but we'll make sure that file 2 only gets created after file 1. And the way we'll do that is when we use the depends on meta argument, we'll pass in the value of the resource address of the first resource that we'd like to create, in this case local file.file1. And once that we confirm that it's all correct, we can use a Terraform apply to apply that plan. And you'll take a look here and you'll notice that file 1 was created first, and only after that creation completed did file 2 begin to even create. And this is how the explicit dependency works using the depends on meta arguments. That's a wrap and the end of this episode of Weekly Bytes, where we covered Terraform resources, the arguments they take, meta arguments, and how Terraform deals with all of that. If you found value out of that, you can like, subscribe, and show your love in the comments. If you don't want to miss one of my videos in the future, you can also hit that bell icon. But in the meantime, if you're a bit confused to how we got here in the first place, you might want to actually start over here.